Hello, everybody, and welcome to what is this is a special event. This is our very first episode of a new show, all about not just AI, but databases for AI, an important primitive that you all need to know about if you're out there in the world building and iterating on AI applications, or if you're just trying to understand how these things are built and how they work behind the scenes. I am Trevor Spires, your host for today's show, and I am joined by the amazing Melissa from AWS. Melissa, for the folks that may not have met you before, let them know who you are.
Yeah, absolutely. Thanks, Trevor. Hi, everyone. My name is Melissa. I am a Neptune specialist solutions architect here at AWS. I've been at AWS just over 7 years now, and the last 4 of those have been spent solely with Neptune, which has been an awesome experience.
4 years on Neptune. I didn't even hear about Neptune for the first time until a couple of years ago. So that's pretty impressive. That makes you one of the original Neptune crew, I suspect. And folks, I'm Trevor Spires. I'm a solutions architect here at AWS, working with customers in the field. Today, you're going to learn all about vector databases and graph databases, how they differ, and particularly by the end of this episode, you should leave with some example code that you could go try, deploy for yourself, and a foundational understanding of when a graph database or GraphRAG may be the right choice for a particular AI agent, AI workload that you're building. So I'm really excited for today's session. And in fact, selfishly, as a curious guy myself, like I've been learning a lot leading up to this show. So thank you all for tuning in. And by the way, if you are here live in the audience, let us know where you're dialing in from today. I'm coming at you from Boston, Massachusetts. Melissa, where are you? Some Amazon
I'm in
headquarters.
Seattle. Yep.
Oh, where it all began. She is in Seattle. Yes. Let us know where you are dialing in from, and we can throw your comment up on the screen. This is a live show, so we will be taking questions live. And with that, maybe we should just jump right into it. What do you think, Melissa?
Yep. Let's do it.
Amazing. I'm gonna throw the presentation up here real quick, and we're gonna dive right in to some topics here. And I think a great way to kick things off to contextualize this is like, what is vector search? And then we can ground on that to help people understand how that differs from GraphRAG. And by the way, we've got folks from across the globe: India, Virginia. Our BFF Lauren is coming from Jersey City, all over town. But let's get into it. Let's start with that first slide here, Melissa, on what is vector search. Now, folks in the audience, I don't know if you've played with vector search. You may have heard the term vector database. On AWS, that's oftentimes services like OpenSearch or maybe Postgres. There's even a S3 vector database these days. But fundamentally, like what a vector database does and when you would use it in an application is to find what is commonly called like semantic similarity, right? So there's like an algorithm that's running behind the scenes where when you query, the vector database is going to return words or phrases or chunks of data that are similar to whatever you sent in to that vector database, right? And I don't know about you, Melissa. Like I've seen that as a pretty effective mechanism for certain things. Enterprise search, for an example, I've seen this be a pretty powerful tool there. And it's also, funnily enough, like it just happens to be like one of the first things. Like if you take an AI workshop, it's like one of the first things that you tend to learn is RAG and vector databases.
Absolutely.
Yes. Do you remember setting up your first vector database? I felt like a superhero when I set up my first vector database.
Maybe I'm biased, but the first vector database that I set up was actually Neptune Analytics, which is not just a graph store, but it's also a vector store. So you can actually keep your vectors and graphs in the same place with Neptune Analytics. So that's fun.
Love it. Yeah, I think my first one, I actually set up a Pinecone vector database back in the day because I didn't work at AWS, and so they offered some free vector database offering out there. And these days, I'm doing a lot of OpenSearch, a lot of PG vector. I think that's sometimes a blessing and a curse of being at AWS is we have all of the databases you could possibly need for any problem, and sometimes the challenge is figuring out what's the right one for my particular use case. Now, so vector databases and vector search helps us find semantically similar results. However, that what I've been learning talking to you, Melissa, is that actually leaves a gap. Yes. Because there, just that you may need to search something that is related in some way to the phrase that you're querying, but it may not be semantically similar. Like the way it gets tokenized and embedded into the database can sometimes be trickier than just like, does the word have a similar meaning to the one that I've entered? Is the word similar in the vector database's vocabulary, right?
Yep, absolutely. And like you mentioned, vector search is really great for helping us find things that are similar in meaning to a given input. But depending on the types of questions that you're asking, what if the relevant information for answering that question is actually related in some way that's not necessarily just similar in meaning? And that's kind of where the graph search comes into play. And so really graphs are just a way to show how different information can be connected in some way that doesn't necessarily have to mean similar. And a really common example of a graph that we all know and love is the social network or the social graph, where you're on LinkedIn, you're on Facebook, I have friends, my friends have friends, their friends have friends, right? And you kind of build out this mental model of a very highly connected network of friends and friends. Now, connections and relationships can represent all different sorts of situations. For example, you can have parent-child relationships. Information can be related through cause and effect. You can have sequential or some time-based ordering of events that connect to each other in a certain order. You can even have like taxonomic or hierarchical or ontologies that kind of tell you how certain concepts within a domain are related to each other. And so all of this different types of connections all provide relevant information that is not necessarily semantically similar, but it is related in some way and can be important for answering a given question.
I'm kind of curious, in your experience, like how when you're working with customers or you're talking to customers in the field, like how do you, is it something you've built like an instinct for? How do you come to the conclusion of, oh, this is a problem that would be solved by something like graph? Like, are you asking questions about, are there parent-child relationships, cause and effect? Maybe they give you maybe they just give you a query and then you can kind of fill in the blanks of what we need on the back end. I'm kind of curious what your mental model is to decide, oh, this application would be worth exploring GraphDBs for.
Yeah, so there's kind of two main things that I look for as indicators of a good general graph use case. So the first is the data set that you're working with full of many-to-many connections? So kind of like that social network example, that is a data set that's naturally full of many-to-many connections, because you can have one person that has maybe only 5 friends, but maybe their 5 friends are actually celebrities. And each of those friends have like 1,000 friends. And so you can quickly kind of visualize there is a really big fan out in that hierarchy. So that kind of ticks the checkbox of, am I working with a highly connected data set?
Makes perfect sense.
Yep, exactly. And then the second aspect is actually, for the questions that you want to ask of that data set, do they require knowledge of how things are connected together? Because we can imagine that, let's say I'm building the newest social networking platform. If all I really care about is fetching people's username information or personal details, I don't really care about making friends of friends based recommendations or doing any type of like community clustering. Those types of data access patterns, they don't really require a graph, because if I were to model that as a graph, it's essentially the equivalent of a one-hop lookup, which I could just use like a key value store or something else for those types of access patterns. Now, if you were to say, I'm building a new social network platform, but I also want to do some type of clustering, so clustering users based off of similar interests or similar overlapping in friend group, or maybe I want to do some friend recommendations that are based off of like friends of friends. Those queries, I'm going to need to know how each person is connected to everyone else in order to answer those questions. And so that ticks the second checkbox for the questions that I need actually utilize the connections in that graph data.
That makes sense. And somebody in the chat asked a question that I think can help us even make this more real for folks that may not be able to make these connections in their mind. It's like, what I think vector databases are often kind of the default choice for things like search or like and like a good example is like FAQs or like maybe at Amazon we used to have like 10 different wiki pages, but now I can just use like a vector database style search and index over all of those pages. It's like enterprise search is probably the most common vector database or RAG use case. But you and I were talking a little bit yesterday, Melissa. A really common use case that I see customers using AI to solve today that GraphRAG or Graph in general can help support is something like a fraud or a financial crimes investigation, where you might be needing to see an event like a user made this transaction, but also they signed in from a different location at the same time, and these are not semantically similar in any way, and so it wouldn't make sense necessarily for somebody's login event and a transaction to be returned in a vector database. But it sounds like the secret sauce of Graph is its ability to make these connections between things that may seem dissimilar at face value, or if you're just looking at them semantically anyway.
Absolutely. And kind of the way that I see the analogy between vector search and graph search is that we think of vector search as being able to place like sentences of similar meaning close together in the vector space, whereas the analogy to graph would be closely connected concepts or closely connected entities are going to be closely connected in the graph as well. So if we think of the graph in terms of nodes and edges, so like little dots and then the lines connecting between them, closely connected concepts will be very closely connected in terms of the number of hops between them.
Love it. And for those of you who are here live or even watching the recording, here's we have a landing page that we're going to use for all these shows. This is the first episode. We're going to continue making content like this. So if you like it, first of all, you might want to subscribe or comment or whatever on whatever platform you're watching this from, so you can catch more of these shows weekly. But I threw a link in the chat so folks can kind of get a sense of what's coming next. More to come there. So this makes a lot of sense to me. What else? What else do we need to know?
Yes, I think the next logical question is when or why should vectors and graphs be used together? So we talk a lot about situations where a vector search alone is going to be great for certain use cases like enterprise search. Graph alone is going to be great for use cases where you just have questions that need to know about the connectivity. So like those social network type questions, or as you mentioned in a fraud graph, a really common pattern that we use is representing different entities in the fraud problem, like credit card users or bank accounts, personal information like addresses, phone numbers, IPs, so on and so forth. You can have like a little network of how all those attributes might be shared amongst different users and accounts, and then use graph query patterns to kind of pick out patterns of suspicious behavior. Like, why are multiple accounts with the different social security numbers all using the same address, or even the reverse, right? So you have situations where it's clear cut, I need vector search for this. You have situations where it's clear cut, graph makes sense for this. But what about situations where you want to use both of them together? And that's kind of our focus for today. And so I really see kind of two main patterns for this, which we'll talk through with a few examples on the following slides. The first is what I like to call hybrid queries. So it's really just a combination of a vector search plus a graph search. And depending on the order in which you do those, you can kind of fit different use cases. The second use case that we see is what we call GraphRAG. And for our context today, GraphRAG to us does include a vector search and a graph search. I know some terminology refers to GraphRAG as just doing the graph search within a GraphRAG, but for us, we're actually going to be combining both vector search and graph search in order to improve the retrieval of relevant context that will then feed to our LLMs.
Yeah, this is one of the most fun things about getting to work in an engineering or like architecture role on AWS is because like sometimes you can get even the title of this episode, like sometimes you can get wrapped around the axle, like is it path A or is it path B? But you know, we're engineers. You know, combining two different systems is usually just a few lines of code away, and so you can really. It sounds like there's a growing pattern and momentum for people to get the best of both worlds out of these solutions. The audience has been awesome and active in asking us questions so far. I have a question for all you folks that are tuning in live today. Is this your first introduction to Graph Database? Like maybe you could let us know where you're coming from if you're kind of like a Graph newbie and this is your entry point to Graph, or if you're already a Graph whiz and you just want to see the demo so you can understand all the awesomeness of Amazon Neptune. Helps us understand where people are starting, because we're gonna keep making content like this. And it looks like across the board, a lot of folks are fairly new to Graph, which, by the way, you're in great company, because so am I. I've seen a lot of great Graph demos, but I think I'll just be honest. For me, my interest in Graph is kind of experiencing a resurgence because of AI. Because back in the day, I was like, okay, I don't work for a social network company. I wasn't doing a lot of fraud, so I didn't understand where I would use it. But it makes to me, when I think about like an AI agent and how complicated it is to actually load the right data into the context of an LLM, this feels like a really important tool for builders to have in their stack. So before we move on to the next one, we got a great question I want to run by you here, Melissa, which is they're asking if this could be useful for searches across an organization. Maybe you have maybe there's some tagging, and maybe you're going to cover this in the demo. But what I love about this question is the gears are starting to turn. The people in the chat are starting to think, okay, where does it make sense to introduce RAG into the conversation?
Yes, so you absolutely can do that. I guess I'm thinking of this question more from the perspective of GraphRAG, where maybe you have different teams internally within the same company, and they each have their own repository of documents, and maybe some documents on some topics can overlap with other teams. You might also have situations where there could be like a multi-tenancy aspect to it, where you've got some teams that are like super teams, and they should have access to everyone else's documents and be able to search on that with GraphRAG, but the reverse is not necessarily true. And so within graphs, you do have the ability and the flexibility to kind of implement multi-tenancy control like that, which I'll touch on a little bit when we get to the GraphRAG demo. But yeah, definitely doable.
Amazing. Yeah, let's see what's next. And folks, while Melissa's moving forward, I did post for me, sometimes I can talk about something 10 times and it doesn't really click until I just do it. And so I want to make sure you all know we actually have a workshop that you could load into your own AWS account, or maybe you have your friendly neighborhood solutions architect or TAM that can run a workshop with you in a sandbox account or something like that. But posted a link to that in the chat here for folks that are eager to just start building and understanding how they would apply this in the real world. So anyway, tell us what we need to know about hybrid queries. That sounded like an interesting one.
Yes. So hybrid queries are really just combining vector and graph search together. So this is not necessarily just scoped to kind of GraphRAG and AI. Certainly hybrid queries that combine a vector and graph search, we actually do use them as part of GraphRAG, which we'll talk a little bit more about shortly. But it doesn't necessarily have to be a GenAI related use case. And really, two ways that we can see this being done is either doing a vector search first to find similar information, and then doing a graph search from the top K results that you yielded to find other insights out of your graph. And then, of course, you can do the reverse. And so kind of talking through what each of these strategies do. So vector search first. So essentially, we're going to use a vector search to find some similar information. And then from that similar information that's surfaced, we can do a graph traversal to find the other connected related information. And an example that I want to use for this is an online retail platform. So let's say that we have an online retail platform and our user comes in and we're going to use a semantic search to help them find what they're looking for. And so someone comes in and they're looking for an electric toothbrush and make sure it's rechargeable. And so what we can do is, a logical first step to take here is matching on the product descriptions and using vector similarity search to find products with similar descriptions to what that user is searching for. So that'll surface some cool models, hopefully the latest, newest models of electric toothbrushes. So that kind of fits the first half of that vector search. And then let's say that someone actually does put one of these top K products in our cart. Now, we're at the point where we want to maybe make some additional product recommendations for this person. I don't want to recommend them more electric toothbrushes because they probably only need one. But what if I can recommend them complementary products? So products that are logically used with whatever product that they just added to their cart. And this is where the graph comes in. So we can have a product domain expert that kind of generates this product ontology for us, where we are able to map like each unique individual model of the electric toothbrushes that we surfaced in our search. They're actually a type of electric toothbrush. Electric toothbrushes are subclasses of toothbrushes, right? Because you can also have manual toothbrushes. And toothbrushes, we know, are used for oral hygiene, right? And it turns out that there's also a lot of other tools that can be used for oral hygiene. So we can kind of traverse down that bottom right subgraph to find what other products might be complementary to this product that we just recommended someone through semantic similarity search and they put into their cart. And so that takes us down to, those electric water flossers, which I've never tried, but they seem
oh my gosh,
good.
Wait, hold on. Sorry, let me interrupt. If you've never tried a water pick, you've got to get a water pick. This will take your dental routine to the next level. I won't get on my oral hygiene soapbox right now, but we've got folks saying, people cannot live without the water pick. So there you go. Run a nice hybrid search query on Amazon.com or whatever, and find yourself a high quality water pick. Oh, Isaiah, thanks for coming along, man. Happy to see it in the chat today. By the way, this example makes perfect sense to me, right? Because it's a good example of. Well, I guess I'll let you proceed. But is this? I guess my question is: is this flow? Is that oral hygiene connection? Is that powered by Graph here, or are we just looking still at pure vector search right now?
Yeah. So everything to the right of the toothbrush boxes would be powered by the graph. So the way that I would think of this would be, what you have in your product graph would be individual nodes to represent each product and their specific model. So that would be like the individual toothbrushes and then the water pick. And then we'd also have graph information that represents the product ontology. And so the product ontology will contain information about how different models of certain products belong to certain categories of products.
Got it. So if I'm thinking about it the right way, and you can correct me if I'm wrong, is like by doing the search for the electric toothbrush with charger, like obviously you're going to get a top rated toothbrush back if you've got a reasonable vector search, but maybe there's like a recommendation or an additional item you might want to add to the cart, and that sounds like is powered by this flow of like, oh, well, we know that electric toothbrush is in this oral hygiene category, which might lead you to surmise that a flosser or some floss or toothpaste or whatever that doesn't necessarily match the search of electric toothbrush, but is still highly relevant to that shopper or that person that's trying to. So I love this example, because dental hygiene is very important, but also because I think it helps me contextualize like how Graph can, like, you could just have made this app return a toothbrush, but now you're talking about really improving customer experience even further with something like Graph connecting additional recommendations. And so I guess that's a question I would have for you, Melissa, is like some sort of recommendation engine or personalization. Is that a use case that we see often for RAG in the world? Or not for RAG, sorry, for GraphDB in the world, I should say.
Yes. Yeah, absolutely. We do have customers that are using graphs to kind of represent this product ontology. We actually have a customer case study that we have on our AWS Neptune blog that actually shows how one of our customers represents their product ontology in Neptune and uses that to kind of feed into their retail shopping flow.
Very cool.
So yeah, definitely. And yeah, just the last thing to hit on this, which I think you mentioned, Trevor, was, but really just wanted to highlight that, vector search is still really valuable here for us because it helps us find those similar items that someone is looking for. And then Graph is kind of adding the extra relevant but dissimilar information, which is in the form of our flosser. So our flosser is not the same as our toothbrush, but it is still relevant because we want to have nice smiles and take care of our teeth. So.
Love it. Oh, wait. So now we're doing the opposite. We're going Graph first.
Now we're going to flip it.
You're going to blow my mind here. I actually hadn't thought of this as a workflow.
Yeah. So kind of the second pattern we see is doing the opposite. So instead of finding the starting points of our graph search through the top K, we're actually going to use vector search and vector similarity as more of like a filtering mechanism for our graph results. And just a quick, simple example of this, we're kind of going back to the social network example where I'm building the latest and greatest social networking platform. And one of the friend recommendation algorithms that I want to use is going to be the tried and trusted friends of friends. So what I'm going to do here is I'm going to use a graph search to first find my friends, and then I find the friends of my friends, make sure I'm not already direct friends with them, and then serve that back as some recommendations. Now, the problem with this recommendation algorithm as is you could have the situation of your friends of friends list is actually going to be huge, right? How do I know how to just surface maybe like the top 10 friends for me to try to be friends with instead of giving me a list of like 1,000 people that I should be friends with? And so one way that you could think of kind of capping that list and making it more relevant is saying, well, we could aggregate the number of mutual friends that are between me and each prospective friend and then sort. Another way that we could think about this is, what if we were to apply a filter based off of semantic similarity? So maybe I've got like a textual description on my profile of my hobbies and things I like to do. What if I can just calculate the vector distance between my user profile and then the prospective other ones, and then filter, sort, and rank by whoever has a profile that is most similar to me. And then, of course, they're my friends of friends and we're not friends yet. And so we can use the vector search to kind of add and enrich a little bit of additional information in order to help us filter, sort, and rank results that we yield from our graph search.
Got it. So if I could summarize that, it's like, it sounds like, especially, this makes sense because once you have like 2 or 3 relationships removed in a graph, you might have thousands or tens of thousands or more results. And so you can tag a more traditional like KNN or vector search at the end to then find like which of these thousands of options that were yielded from the graph search are most relevant to return to the user.
Yeah, absolutely. All right, so we put together a sample for y'all to try out that touches on hybrid search. So the data set that we're using here is actually medical journals from PubMed, and we show examples of how you would get that into a graph format. Of course, we're going to chunk and vectorize it and put it into a vector store. And then we're going to show you some of the differences between what types of searches would be great for a pure vector search, pure graph search, and also situations where they would go well together to do that hybrid search.
Amazing. Yeah. And for those folks watching the recording, we'll make sure we put a link to this in the description. So that way you can go try it out for yourself.
Awesome. So now we are getting to GraphRAG.
All right, we made it to the buzzword.
Yes,
GraphRAG is definitely the buzzword, and we made it here. I feel like it's funny. I feel like lately it almost is like graph and GraphRAG is like almost synonymous. Which obviously they're different, but I feel like I just feel like I see GraphRAG used in the industry, and so really excited we get to dig into it. By the way, we got a question that this might be a hard question for you, Melissa. All right, I'm gonna throw it at you. Let's see if you can handle this one. Neptune is graph?
Yeah. Yes.
The answer is yes. Neptune is graph. So we're talking one. I think at Amazon we take a really customer obsessed approach to working with our customers, right? And so graph is a technology that you can use in a lot of different places. We have a really great managed service for graph, which is called Neptune. So if you're just getting started with graph, I would suggest starting with Neptune because it's a really easy way to get started. It's fully managed. You don't have to think about hosting the databases and scaling it and all of that kind of undifferentiated heavy lifting. But there are also really popular options out there in the open source land. I think Neo4j is one that I feel like I hear about a lot out there in the world for those folks who are wondering. So we're talking broadly about graph today, but if you'd like to dig into a specific implementation, reach out to your AWS team and they can help make sure you get connected with a wonderful graph expert like Melissa to get that journey started.
Awesome. So before we talk about what GraphRAG is, how it works, what is the architecture like, I wanted to start with an example situation and then apply kind of like a VectorRAG lens over it. And then we can compare that same situation with a GraphRAG lens over it. And so the example that we are going to be talking through today is, let's say that we have a repository of different journal articles, press releases, news reports, things like that. And our document repository has a lot of information that talks about this brand new example corp, and they're selling these shiny new widget toys. And you can see that here on the screen, I've popped up just a few highlights of some of the information in our document repository regarding this new example corp and the widgets that they sell. So you can see we've got some information about how example corp partners with this any company logistics company. We've got a news article that's anticipating a huge Christmas demand for these new widgets in the UK. We've also got some information about how this logistics company is able to make shipping times faster by using this turquoise canal. And then we've also got some articles about the turquoise canal and, unfortunately, how it is blocked, which is thus causing delays. Now, if I was a researcher and I am tasked with answering the question, what are the sales prospects for Example Corp in the UK? Now, if we're to look at this from just a VectorRAG perspective, our flow is basically going to look for chunks that are semantically similar to what is being asked. And so the question that I'm asking, some of the keywords that pop out to me are sales prospects, example corp, and the UK. So that means similarly, our VectorRAG is going to extract chunks that are similar in meaning to sales prospects, example corp, and the UK, which we'll pick out some chunks here that are similar in meaning to our original question. Now, if we're to pass this subset of chunks to an LLM, it's going to infer that sales are going to be great just based off of the 3 chunks that we've selected here. However, we can see that there are actually other chunks of information like these bottom 2 that are actually related and necessary to provide in the context in order to provide kind of the full picture of what is happening with these sales prospects. And so that's kind of where
really, by the way, if you don't mind going back to that real quick, this is really interesting because I could see a scenario where like you're a customer and to you this looks like a hallucination, right? But actually the AI is just giving you the best answer it can based on the context. Really, this is what you're describing here as a context engineering problem, right?
Yeah.
And so I don't want to steal your thunder. So tell us how does Graph solve for that missing context? Because from what I'm seeing here, sales may not be so marvelous if the turquoise canal is indeed blocked.
Yep, absolutely. You're right. And I mean, in RAG, right, context is king. We really just need to make sure that we are surfacing all of the relevant context that we actually need in order to answer that question. And as you kind of hinted towards, that's really where graphs come in, right? Because earlier we talked about how graphs can help you find relevant information that is not necessarily similar, but it represents some type of relationship. And in certain use cases, understanding what relationships exist can be important to making sure that you are providing the full context that's needed to accurately answer the question. And so if we were to look at this with a GraphRAG lens, again, our definition of GraphRAG, we are including a vector similarity search plus a graph search. So we are still using a vector similarity search to kind of find inputs into the graph, and then using a graph traversal to collect any other relevant information that is related, it's connected, but maybe dissimilar. And so that's where we kind of pick up these extra 2 chunks on the bottom here, because even though the chunks are talking about the turquoise canal, which isn't semantically similar in meaning to sales prospects, for example corp in the UK, it's still relevant because we know that example corp is using this logistics company, and we know the logistics company is using this specific canal, but that canal is blocked. So when you kind of connect the dots to form that full chain of thought and then provide that full context to the LLM, they would then correctly infer that actually sales are going to be negatively impacted, because we can see that the use of this canal through the use of this logistics company is going to be what is blocking a lot of the delivery and shipments of these widgets.
So I have a question. This is a question that popped into my head just thinking about my understanding of graph. Like, so in GraphRAG, is there still a step of doing like an embedded, like an embedding that you load into the vector database? The reason I ask is I'm trying to get a sense of if it has some of the same characteristics of vector database where you would need to like load the data in advance, or if it can do like real-time queries or something like that. So yeah, could you just briefly share like is there some embedding mechanism to load the data in a situation like this?
Yes. Yeah. So with our GraphRAG flow, there still is an aspect of vector similarity search, because really to generate the full context, like the full complete picture, we need similar information and we need dissimilar but related information. And so a vector similarity search still does a great job of fulfilling that first role of helping surface the similar information, because we still do need these top 3 nodes in order to kind of put the big picture together. And then where the graph comes in is helping us find the related but dissimilar information. And so that question actually kind of transitions nicely to the architecture. So this is at a high level how a GraphRAG architecture flow works. And so you'll see that there's a lot of overlap and similarities with how you would do like a standard VectorRAG workflow, where you've got your data sources, you're doing some type of chunking in order to break out context into discrete pieces of information. We're still doing embedding generation and storing that in a vector store. The main difference here with GraphRAG is really the graph, because the graph is going to be key to helping us find and surface all of that relevant data that is not necessarily semantically similar. And so depending on what tools you use to build GraphRAG, some of the steps in this flow might look a little bit different, but really at a high level, it's you have some data sources, you're breaking down into chunks, so still following the same process as VectorRAG. We're adding an extra layer on top of the processing to do things like entity extraction, entity relationship extraction, and also including some data lineage in the graph, which we'll talk about in a second. And then you'll notice that the actual querying and retrieval part of that architecture is similar in a way to RAG, where we're finding some entry points into our vector store based off of the semantic similarity search. Based off of those starting points, we can do a graph traversal off of those starting points to find additional related and relevant information. Once we find everything that we need, we can then pass that context to the LLM and then come up with a nice answer.
Yeah, I love this diagram because it helps contextualize for me that like if your organization, or even if you have already built like a typical RAG pipeline, you likely have a lot of the components and skill set in place to take that a similar mechanism and apply it to GraphRAG. I want to make sure we have time to dig into your demo, so we should probably get to that next. But I got a couple of rapid fire ones for you, and then we can make that transition. So while you get your screen up, I can take this one. I think some folks are wondering if there's any compliance specific things, or like if this is more relevant in verticals. I can't. You could probably speak to that better than I could. But what I have personally seen is a lot of. I was just looking at the Neptune reference page. I'll share that in the chat. There seems to be a lot of like financial services customers that are using RAG for different use cases, but it seems to be across a variety of industries. So I don't imagine maybe there's some compliance use cases out there, but I don't imagine it's a blocker to adopt from like a compliance point of view. And to somebody was kind of trying to confirm their understanding, but like essentially, I think maybe this is an oversimplification, but I like this description of like it's really just a combination of finding both similar results and also interconnected results that may not have been found in typical semantic similarity, which is to me makes it sound very powerful, because it feels like a solution with GraphRAG or a hybrid RAG, like you iterated, can do both. Like it could do just semantic similarity, or it could do semantic similarity and these interconnected relationships. And you know what? We could keep talking about it, but one great way to make it real is to just kind of show folks what this can look like in action.
Yes. So just a little context about what we'll see in a second. So we're still running with that same kind of problem set that we saw earlier about Example Corp. So we have a few different articles about Example Corp and the widgets and how it's revolutionizing computing, Turquoise Canal, all that good stuff. We've implemented kind of a very simple RAG search to answer that same question, as well as a GraphRAG implementation, and we can kind of compare and contrast where we see some of those differences. All right, so with our vector search approach first, we are going to ask the same initial question. So what are the sales prospects for example corp in the UK? I'm just going to pick 5 chunks for now. The total data set that we're working with is an example data set. So we've got 35 chunks total, just to put the chunk count into context. Let me close that. All right, so if we skim what the response says, let me zoom out a little bit just so we can see the full response in one page. We see that based off of the context that we've provided to the LLM from a vector search, we're going to have good sales prospects for example corp, which is awesome. Right, as we know that's not actually the answer, but if we dig into a little bit more what chunks were used and what sources did they come from, this is just a little visual to show the 5 chunks that were surfaced. Right, so we've got 4 chunks that came from this one article on revolutionizing personal computing. And we've also got 1 chunk that came from Countdown to Christmas, which is kind of like a news article predicting the popularity of widgets in Christmas. So we can see that based off of the source titles, we're missing out on articles that talk about like the logistics partnerships, as well as the issues with that canal being blocked. We can do another representation here just to show how any of these chunks are related to the same topic, if at all. And we see that out of the 5 chunks that we have, only 2 of them really have overlaps talking about the same thing, which is example corp's widget, which makes sense, semantically similar, and then also example corp and the logistics partnership. All right, now let me switch over to asking this exact same question, except with GraphRAG. And the way that we have implemented the GraphRAG application on the back end, there's actually a few ways that you can do it. We're using today the GraphRAG toolkit, which is open source on our GitHub. And GraphRAG toolkit basically is just an open source set of tools and frameworks that make it easy to build kind of GenAI GraphRAG applications. So if we scroll down and take a look at the response it gave us, overall, it's still pretty positive, but you'll notice that there's a little bit of nuance towards the end where it's making note that that supply chain disruption actually might make it challenging for positive sales prospects in the UK. And so where the big difference is, right, because we saw in the vector search, we're servicing the top K, which in our case is 5, top 5 most relevant chunks, so chunks based off of semantic similarity. Where the GraphRAG comes in is our graph is actually not treating the chunk as the unit of context, but we're actually treating something called a statement as the unit of context. And the statement is, it's kind of like a sentence that is a lot more granular than what a chunk would provide. And so this is a visual showing all of the information that we have pulled out as a result of our GraphRAG retrieval. And we're showing how that information relates together and how it eventually gets fed downstream to the LLM. And so we talked about our unit of context is the statement, which are going to be like these pink nodes here. And we can see that statements are just individual sentences that state something. So this example corp develops the widget. It's a US-based tech company, so on and so forth. And so if we zoom out a little bit, so what actually happens behind the scenes is for this GraphRAG flow, what we feed to the LLM is actually statements and the relevant topics. So we don't actually feed them the chunks, we feed it all these individual statements and the topics. And you can see that in our graph model, we still have links that show how topics come from certain sources and how those sources come from certain documents. And if we zoom out a little bit, you can see immediately that before with the vector search, we were essentially only looking at answers across 2 different source documents. But here, the green nodes are representing our source documents. We are actually pulling across 1, 2, 3, 4, 5 different source documents. So we're really able to kind of expand the relevant search across multiple documents because we are utilizing connections between related but dissimilar information.
Okay. What is the UI that is helping us kind of dig into these relationships, by the way?
Yeah, so I am just using a Streamlit component that builds the graph. I think under the hood it uses either Cytoscape or BizJS. I have to check.
Got it. So
it's using one of
like
those open source components.
Got it. Okay, cool. Yeah. Just curious. And folks, if you want to try this out yourself, I just want to reiterate there's a workshop. You can pop into it. You can start playing with this underlying technology anytime. Now, I've got an engineering question here that pops in my head based on what you're showing me, right? And that is one thing that this visual made real to me is certainly we're getting a lot more context in when we do this graph query, which is awesome. But sometimes historically, sometimes that can pose a challenge because you're bringing in too much context, and you might actually constrain the context window a bit. Thankfully, I mean, LLMs have made a lot of progress in the last 6 to 12 months in terms of like identifying important details over a large set of context. But I guess my question is, do you find these use cases, do you find context window and maximum context length a restriction in these use cases, or am I just overblowing the problem because I see all these dots on the screen?
Yeah, so it actually turns out that I would say that the context window, it's about the same size more or less as kind of the vector search that we saw previously. And the reason being is that we're passing in all these topics, right? We're passing in all the pink nodes, which is quite a few, and all the blue nodes. But each pink node, each statement, it is pretty short. It's like about a sentence in length.
So yeah, okay. So since you are pulling this up, this makes sense because it's an ID and then a very short. It's not like each one of these represents a paragraph. This is like 10 tokens or something, you know?
Exactly. Yeah. So what it kind of looks like is we feed it the topic. So the topic will be like example corpse widget, and then just stitch together each statement value. So like we'll stitch together just this value and then feed it this one, and then so on and so forth, and then just do that for each topic. So we'll feed in each topic and then all the statements relevant to their topics. And because each statement is individually quite small, token wise, it comes out to be very similar to just the standard vector search.
I love it. Anything else you want to highlight in the demo here, Melissa?
Yes.
This has been super comprehensive.
One other thing I wanted to show is, so we actually have one more graph visualization here. One thing that I know we didn't have time to touch on yet, but in terms of the graph model that we use to kind of power the relevant but dissimilarity searches, it's what we call a lexical graph. And a lexical graph pretty much has a few different layers to kind of help us find all of this relevant and dissimilar information. One layer of which is an entity relationship layer. So this is pulling out entities that exist and are discussed as part of our data sources, and also how they relate to each other. And so these entity to entity relationships, so for example, this entity is Taiwan. Any company is right here. All right, so we can see any company is related to the Turquoise Canal through, well, it plans to use the Turquoise Canal, and then it also actually uses the Turquoise Canal. So you can see that, we've got this entity to entity diagram of how all the different mentioned concepts are related together. And this is actually used as part of the retrieval process in order to help us find that relevant yet dissimilar information.
Amazing. I mean, and just to kind of tie things off, as you were speaking today, I was multitasking a little bit and nerding out on all of the amazing use cases and customer examples that we have on the Neptune page. So for those folks that are like heard today's session and are ready to dive in, or maybe if you still need some inspiration on kind of like what type of problems we can apply this to, it's like it looks like this is a really popular tool for like cybersecurity companies like a Trend or a Wiz that need to like build relationships between a lot of different topics. Like I think what is amazing me as I flip through all of this case studies and use cases that we have on the page is just like that this is, I think, I could be wrong, but I think the industry may have a perception that this is kind of a niche technology. And I'm starting to believe that that's not the case. Actually, this is a general purpose technology that can be applied in any industry. And it's all about finding like, what is the problem space, or what is the limitation of some other sort of query or some other sort of database system that I'm running that I could fill with something like Neptune or something like Graph. So super appreciative of you joining us today and kind of helping kick this thing off with us, Melissa. It was an extremely informative and educational session. For those folks that are still hanging out, please tell Melissa that she's great, and we would like her to come back for future shows to teach us more about GraphDB, because this one was a lot of fun. And for those folks that would like to take the next step of digging into Graph or getting hands-on with Graph, just check out in the description or in the comments here. We do have a link to the workshop. Here we go. Make it even easier for you. I see Melissa pulled up a QR code if you want to use that to get yourself navigated to the workshop and start getting hands-on with this technology yourself. And surprise, Melissa, you've got some fans. People are digging the show. It was useful for folks. Thanks everybody for tagging along with us. And by the way, if you didn't catch it at the beginning, this is happening every week. We're going to be running this database for AI series every Thursday, same time, same place. So if you like this one and you want to learn even more about all of the different ways you can apply technologies like Graph or vector databases, or even just traditional database and storage queries within your AI applications and agents, be sure to tune in again next week and the next week and the next week, because we're going to keep these things coming all throughout Q1. Melissa, before we send folks off to enjoy the rest of their week, do you have any words of wisdom, any last comments, anything you feel like we missed that you want to share with the audience here before we wrap this one up?
I think we touched on a lot of great topics today. I would just say GraphRAG, try it yourself. We've got this workshop. It uses the same data set we use today, plus actually a few others. So you can kind of compare and contrast the situations in which GraphRAG would be useful. So.
Love it. Thank you so much for the resources. Thank you for the time. Thanks everybody for tagging along today. We will see you next week on the Databases for AI stream. Take care, everybody.
Yeah, thank you.